Welcome to this class. Today I am continuing the chapter wave of the subject science and technology of class 10, and we have divided this chapter into different parts. Out of different part, this is fourth part, and in this fourth part we are talking about the consequences of total internal reflection of light and its uses. In previous class, what is total internal reflection is taught. Now we are continuing with the consequences of total internal reflection in our daily life. There are many places where total internal reflection occurs that we are going to do today, and the use of total internal reflection. Okay. Now I want to mention first the highlighted consequences of the total internal reflection by our syllabus. What is told? These are the consequences, major consequences. There are hundreds of consequences, but few are taken. One, sparkling of diamond is one of the consequences of total internal reflection. In the same way, the shining of a surface is another consequence. Shining of the surface cannot be understood looking at this word only. I will elaborate it with example later. Shining of air bubble inside the water and shining of the test tube immersed in water, etc. comes under the shining of the surface. Because of total internal reflection, the object is not seen, but a surface appears to be shining. We'll talk about this also. Now we'll talk about the mirage also. Mirage is one of the great consequences of total internal reflection. And another one, sound can be heard from long distance because of total internal reflection. That also we are going to talk. I mean to say we are going to discuss about this also. These are the major consequences of total internal reflection. Today I want to focus on all these. Okay, but first we must have a little idea about the critical angle and total internal reflection. I want to recall, and then we'll go through consequences. What is critical angle? If you remember, when light enters from denser to rarer medium in such a way that angle of refraction in rarer medium is 90 degree, then its corresponding angle of incidence in the denser medium is called critical angle. Critical angle is that particular angle whose corresponding angle of refraction in rarer medium is 90 degree. It was taught in previous class, just recall only. Just remember this, when light passes from denser to rarer medium in such a way that the angle of refraction in the rarer medium is 90 degree, then its corresponding angle of incidence in the denser medium is called critical angle. And critical angle for different medium is different. Critical angle of diamond is very less, 24 degree. But just opposite, not 24, 42. 42 degree is the critical angle for glass, and 49 degree is the critical angle for water. It was all done in previous class. This is just the recall only. What is critical angle? Now, let's talk about the total internal reflection. If light is traveling from denser to rarer medium this way, with an angle of incidence greater than critical angle, if angle of incidence is greater than critical angle, then instead of refraction, it reflects back in the same denser medium. It's very interesting. Light is traveling from one medium to another medium, but not entering into the second medium. It is again reflected back to the same denser medium, and at this time it follows the simple law of reflection. Angle I is equal to angle R. In this case, I is angle of incidence, C is critical angle, R is angle of refraction. And if light is traveling from denser to rarer medium in such a way that angle of incidence is greater than critical angle, then it reflects back in the same denser medium. This process, this reflection, special type of reflection, is called total internal reflection. In this case, light reflects back, 100% light reflects back, and the light follows the law of reflection. Okay, now after the recall of this critical angle and total internal reflection, just remember this: angle I is equal to angle R, and this total internal reflection can be defined this way. Total internal reflection is a phenomenon or a process in which a ray of light traveling from denser to the rarer medium with an angle of incidence greater than critical angle reflects back to the same denser medium. Okay. Now after this, I want to come back to consequences. What I told you, these are the consequences major we are going to focus today. Sparkling of diamond is because of total internal reflection. Have you noticed that diamond is cut in such a way that it has many faces? Its surface, it has many surfaces, it has many faces, and its critical angle is very less, 24 degree. When light enters into this piece of diamond, which is cut very nicely, then what happens? It follows total internal reflection. When it tries to move out from the diamond piece, then total internal reflection occurs and it reflects back in the same diamond. And when it strikes another face, again it reflects back. There is multiple total internal reflection, and because of this multiple total internal reflection, and in this case 100% light reflects back, when it comes out from this diamond, then the diamond appears to be sparkling. And if a person is wearing the ring having diamond, and if it is moving, then at some time the total internal reflection becomes more, and sometimes total internal reflection takes place from one face, sometimes from another face, and in this way it seems to be sparkling. The sparkling of diamond is because of multiple total internal reflection. Okay, this is one of the consequences of total internal reflection. Now let's have second, shining of a surface. What it means? I want to explain this. Shining of the air bubble inside water. If we have water in a vessel, then usually some of the bubble of air is attached to the surface, inner surface of this vessel, this way. And this bubble appears to be shining from outside. If we see this bubble from outside, it appears to be just shining, not air bubble, it's something very shiny material. I want to describe this nicely with the help of the big air bubble. Let's say we have a little big air bubble. With the help of this big air bubble and reflection, total internal reflection, I want to explain, I want to make you clear. If light traveling from water to air tries to enter into the air bubble, then what happens? It is traveling from denser to rarer medium, water to air. And the angle of incidence is here greater than critical angle. If angle of incidence is greater than critical angle, but do you remember that critical angle for water is 49 degree? If this angle is greater than 49 degree, then instead of refraction, light reflects back. Why don't we do another line, another ray of light also? Look at this ray of light also reflects back. The reason is very simple. Angle of incidence is if greater than critical angle, then light cannot enter into the air bubble. It reflects back from the surface which separates air and water. And if a person is watching from this side, then he or she wouldn't be able to see this air bubble. Since light is reflected back from this surface appears to be shining. And that's why shining of the air bubble inside water is because of this total internal reflection. Light is not entered into the air bubble, but it is reflected back by the surface which separates these two medium. And so this appears to be shining. Okay. Now let's have another example also. The signing of the test tube immersed in water. We cannot understand looking at these words. I want to give this diagrammatic representation here. This is water. If a test tube is tilted like this and immersed partially in water, and if an object is placed inside it, and if you want to see it from the top, from this position, you will not be able to see this object. You will see just the shiny surface only because of the total internal reflection. That's why I am talking about the shining of the test tube. Test tube appears to be shining, but the object cannot be seen. What is the reason? Reason is total internal reflection. Let's say light coming from this side is actually trying to enter from glass of the test tube to the air contained inside the test tube. Glass to air. At last, it tries to enter from glass to air. But at this time, angle of incidence is greater than critical angle of glass, which is 42 degree. We know this, isn't it? Critical angle for glass is 42 degree. And instead of refraction, now it reflects back from the inner surface of the test tube, and when it reflects back and comes to our eye, these rays, reflected rays, are not coming from the object. These reflected rays are not coming from the object until and unless the ray of light reflected by an object comes to our eye, we will not be able to see that object. That's why the object cannot be seen from this position, just this test tube appears shining. This is because of total internal reflection. This is one of the consequences. We can do this in laboratory. Very easily we can understand this with the help of test tube and this vessel, water and an object. Okay, let's have another. Another, what I told you, mirage. This is very interesting. What is mirage? I want to explain in detail about the mirage, how it occurs, how we'll be able to see mirage. But after mirage, I'll talk about the sound which can be heard from long distance at night. Let's have mirage first. Mirage can be observed in desert. Desert is covered with sand, and the sand has very less specific heat capacity. You are taught in the chapter heat. Sand has less specific capacity, around 800 joule per kg degree Celsius. It means when it is heated by solar heat energy, sun's heat energy, in the daytime, it will be heated up a lot, and a hot layer of air forms on the ground, and as we go up, the layer of air becomes less hot. At the bottom, we have very hot layer of air because the sand is hot, and as we go up, this amount of heat will be less and less, and at the upper side, we can say that a layer of cold air forms. This is the comparative matter. This is comparatively hotter layer and this comparatively colder layer. And if there is a tree at certain distance and a ray of light which is reflected by the top part of the tree in the downward direction this way, it enters from denser medium of air to the rarer medium of air, denser to rarer medium. And according to law of refraction, we know that if light enters from denser to rarer medium, it bends away from normal, this way. Now again it enters from denser to rarer medium. As we go down, the medium of air becomes rarer and rarer, denser to rarer again, and again it bends away from normal. Look at this, in every layer, angle of incidence is increasing, isn't it? This angle of incidence is less, this is more than the previous. Angle of incidence is increasing, and a condition comes when angle of incidence becomes greater than critical angle. If it is so, then for the total internal reflection, two conditions are satisfied. Light is traveling from denser to rarer medium and angle of incidence is greater than critical angle. That's why at this point total internal reflection takes place. At this point total internal reflection takes place. Now light is bent towards denser medium. Now it is traveling from rarer to denser medium. And if light travels from rarer to denser medium, then it bends towards normal. Now bending is in opposite direction because now it is traveling from rarer to denser medium. Now if a person is watching this tree from this distance, if someone is watching from this distance, then the angle sustained by the light which enters into his eye is if produced, then the image of the tree appears just below the tree. Because of this bending of light cannot be observed by the eye. What angle the light ray makes with our eye, the same is if produced, then the image of this object appears at its bottom and it is inverted. It gives the impression of being pool of water at the bottom of the tree. Yes, this is very interesting. There is no water at all, but this man will be confused about this tree. There is water just below the tree and its inverted image appeared in this water. And this is called mirage. If he observed this tree this way, I mean to say, if he observed the top part of the tree, then light coming from the same medium comes to his eye and he will not be able to see its image. But if he observed the same at the bottom side, if he look at the bottom side, then this light enters into his eye and the image of the tree appears at the bottom. Tree is also appeared and its image is also appeared at the bottom of the tree. This is called mirage. Yes, this is mirage. We can say shortly, mirage is an illusion of being pool of water at the bottom of a vertical object due to the refraction and total internal reflection of light. There are two conditions, mind it, not only total internal reflection, because of refraction and total internal reflection of light through different layers of hot and cold air formed above the ground in hot summer day. This is mirage. Now if you are told to describe it, I described just before this. Light when comes from tree in the downward direction, it enters from denser to rarer medium, it bends away from normal, and in every layer angle of incidence goes on increasing, and a condition comes when total internal reflection takes place. Again it enters from what? Rarer to denser medium and bend towards normal, and when it comes to our eye, then an impression of the pool of water appears over there where the tree forms an inverted image. This is mirage. This way we can explain with the help of diagram also. Okay, let's have the last one. I mean to say, I made a list and last one was sound can be heard from long distance at night. Why? What is the reason behind this? If someone is producing sound at night, that can be heard from long distance, but in daytime it cannot be heard from long distance. Now what is the reason behind this? Let's have the diagrammatic representation. At night, the ground is cold. That's why a layer of cold air forms just above the ground. This is cold air. Cold air means its density is high, it is denser medium. As we go up, the coldness decreases, and at the upper side we can say that a layer of hot air forms at the upper side. This different layer of air forms at night. if someone is producing sound from certain distance, here the sound waves which is moving upward enters from denser medium to rarer medium. And we know that when sound enters from denser to rarer medium, like light, it also follows the law of refraction, and it also follows the law of total internal reflection. And this sound wave, when enters from denser to rarer medium, then it bends away from normal this way. In another layer also, again it is entering from denser to rarer medium and it bends away from normal. This way, a condition comes when the angle of incidence is very large, and when it becomes greater than critical angle, then instead of refraction, it reflects back in the same denser medium. This is total internal reflection. Till this point, we had refraction of light, and at this point, total internal reflection occurred. Again, refraction starts. When it enters from rarer to denser medium, now it bends towards normal. This way, sound can be sent to very long distance. I mean to say, sound can reach up to the long distance because of refraction and total internal reflection in different layers of air which forms at night. And so, it can be heard from long distance. But what about day? Why not in day it reaches to long distance? Let's have that also. With the help of diagram we can understand. This is different layer of air. In daytime, this ground is hot and a hot layer of air forms just above the ground. As we go up, the layer of air becomes less hot, and at the upper side it will be cold air. And somewhere, if sound is produced and sound is moving upward, this is one of the representation of sound wave moving upward. Sound can move in any direction from the source. If I speak something, then it goes to your ear and it moves towards this direction, this direction, this direction, towards my back also, because of the diffraction of sound. When it is strike, the sound wave is strike my face, it can go back also. So I am taking the wave in the upward direction. Sound wave which is traveling from this hot air to cold air, from rarer medium to denser medium, then what happens? It bends towards normal. And in this layer also, it is traveling from rarer to denser medium, it bends towards normal. Look at this. This sound wave is traveling from rarer to denser medium and going up and up and up. This way sound wave is lost. Not reaching up to the long distance, it is moving up and lot of sound wave is lost and cannot be heard from long distance. This is the story of what? Daytime. In daytime, sound cannot be heard from long distance. Okay, now I think I finished some of the consequences I was listing first. I listed some points and I described about them. Now let's have uses of total internal reflection. Total internal reflection is used in different sectors. Among these two sectors where the total internal reflection is used widely is taken in the syllabus. What are they? Number one, the use of total internal reflection in telecommunication and use of the same process in medical field. In telecommunication, in medical field, total internal reflection is widely used in different purpose. But in both the cases, optical fiber is used for the total internal reflection. In telecommunication also, in the medical field also, optical fiber is used for the total internal reflection for particular purpose. So, first I want to tell you what is optical fiber and then we'll talk about the telecommunication, how it is used, and in medical sector how this optical fiber is used for total internal reflection. What is optical fiber? Optical fiber is an elastic, transparent and hair-like structure. Look at this very small hair-like, very thin hair-like structure, which is elastic also, which is transparent also. And this structure is made up of either glass or plastic, which can transmit light from one end to another end. Very interesting. Why don't we see its construction? Optical fiber. It is used in router also. I think you are used to with router. You know about this. In the router, actually optical fiber is connected and it's very small. I want to give you magnified picture of optical fiber. Then only you will be able to understand how total internal reflection takes place in optical fiber. It is very thin hair-like, but let's magnify it to understand more clearly. Let's say this is one of the very thin hair-like optical fiber. I magnified it to make you clear only. Okay, this is optical fiber. Actually, when we use this optical fiber in particular purpose, it is covered with one of the layer which is called cladding. Cladding is also transparent. This is also transparent layer. Optical fiber is also transparent, cladding is also transparent, but the density of optical fiber is greater than cladding. You have to remember this. This optical fiber is denser than cladding. If light enters from optical fiber to cladding, it is traveling from denser to rarer medium. Lastly, this cladding is covered with plastic coating to increase the strength of this optical fiber. Otherwise, it is very thin and it can be broken down easily. It will break easily. This is the basic construction of optical fiber. Now, how total internal reflection takes place in this optical fiber? Look at this. When light is passed from one of the end into this optical fiber, now it is traveling at this point, it is traveling from denser to rarer medium. What? Optical fiber to cladding. And with an angle of incidence greater than critical angle. So, it reflects back from this point. And when it is strike at this point, again it is traveling from denser to rarer optical fiber to cladding. And angle of incidence is greater than critical angle, that's why again reflects back. This way, in each of these surface where it strike, the angle of incidence is greater than critical angle. It is designed in such a way that all the time angle of incidence is greater than critical angle. So, it won't enter into cladding. It travels in curved path like this. Multiple total internal reflection occurs. And if this light is coming from certain object, I mean to say here we have an object and the object is reflecting light, then this object can be seen from this end. If object is at this place and light is coming from that object, then that can be seen from this end. And light travels in curved path in optical fiber. Okay, after this, let's have one term which is called fiber optics. This is also an interesting term. We have to understand about this also. Fiber optics is the technology that uses glass or plastic fiber to transmit data in the form of light pulses. Data is transmitted in the form of pulse. Pulse is not continuous. Pulse like this. One pulse, another pulse, another pulse. Actually, the data is transmitted from one place to another place in the form of pulse. And this technology is named as fiber optics. Okay, now let's talk about this optical fiber. Why to use optical fiber in communication? In the sector of communication, we were using metal wire. Why metal wire is replaced? Why we are using optical fiber? instead of metal in the communication? The reason is very simple. Number one, data and signals can be transmitted very fast through the optical fiber in the form of light waves. In the speed of light it travels. In the form of this light pulses, it can travel through the optical fiber. Data can travel easily from the optical fiber and it is very fast. Transmission of data is very fast than that of the metal. We cannot compare these two. Metal takes a little time to transmit data, but optical fiber doesn't take a lot of time. It transmits data within the blink of eye. Okay, now next is large volume of data. Large volume of data means what? Per second, even 1 gigabyte. Per second, even 1 gigabyte can be transmitted easily with the help of optical fiber. That's why optical fiber is used instead of metal. Metal is now being removed in the communication sector, and optical fiber is being used instead of metal. Now let's talk about this medical sector. In medical sector, in what purpose this optical fiber is used? We are talking about optical fiber. Actually, we are talking about the total internal reflection, and it occurs in optical fiber. That's why this is the use of total internal reflection. Now in medical sector, endoscopy. In endoscopy, this optical fiber is used. In colonoscopy, optical fiber is used. And in keyhole surgery, these are the three major sectors where the optical fiber is used. I think you have heard about this endoscopy. Somewhere, your family member may have done this endoscopy. Now, what is endoscopy exactly? Actually, endoscopy is a medical procedure that is used to examine the inner side of the upper part of alimentary canal. Inner side of upper part of alimentary canal. Let's have the picture of alimentary canal. Alimentary canal starts from mouth and it ends at anus. Mouth and then esophagus. Wherever we eat something, it enters into alimentary canal through mouth. It goes to this esophagus, and then it goes to stomach, and then duodenum, and then ileum, and large intestine, and lastly comes to rectum. And if any undigested material, certainly undigested material is thrown out through the anus. This is alimentary canal. But what is told here, endoscopy is a medical procedure that is used to examine the inner side of the upper part of alimentary canal. Upper part of the alimentary canal, that is mouth, esophagus, stomach, and the upper side of this duodenum can also be observed with the help of this endoscopy. And if there is something wrong, I mean to say maybe some wound or maybe some problem, that can be seen from outside by this process, in this process. And in this process we are using endoscope. Endoscope is a medical device made up of optical fiber in which a camera is also set to take picture and video. And what we do, two parallel bundle of optical fiber is first inserted into the mouth of the patient, and from one of the bundle light is passed into the endoscope, which when reflects back from the inner surface of the alimentary canal comes to the doctor's eye. Very interesting. We cannot see the inner part of the alimentary canal because it is very dark, but we are inserting what? Endoscope through the mouth, and from one of the bundle light is sent into our body in the alimentary canal, and it is reflected back by the inner surface of the alimentary canal, which comes to our eye. Doctor can see from outside. This procedure is called endoscopy. And in this process, actually total internal reflection takes place in endoscope, which uses optical fiber. Now let's talk about the advantage of endoscopy. What are the advantages of endoscopy? Doctors can see or observe directly with the help of reflected light. What is there in the inner surface of the alimentary canal can be seen directly, and picture can be taken with the help of camera also. If later it has to be reported, then picture can also be taken, then can be seen directly on the screen by the video display also. These are the advantages of endoscopy. Yes. Now let's have another, colonoscopy. What is it? It is similar to that endoscopy, but colonoscopy is related to the lower side of the alimentary canal. The colonoscope will be inserted from this colon, and it is used to observe the inner part of the colon and large intestine. Now, if you are told what is colonoscopy, you can say it is a medical procedure in which the inner surface of the rectum and large intestine is examined. This is rectum, this is large intestine. We can examine this. Means doctor can examine the rectum and large intestine by the use of colonoscope, and the process is colonoscopy. In this process, the inner surface of the rectum and large intestine is observed by inserting a medical instrument called colonoscope through the anus. Okay. Now let's have a little information about the keyhole surgery. Actually, what is it, keyhole surgery? Keyhole surgery is the procedure in which a surgeon operates inside the body through a small, how small? Less than 1 centimeter. Small means less than 1 centimeter incision on the skin. A small hole is made, less than 1 centimeter, and doctor can operate in different organ of our body from this incision. Now, what is done in this process? Surgeon inserts a thin lighted tube with a camera and a laparoscope. This equipment is called laparoscope, through a small incision in the abdomen or pelvis. The laparoscope transmits images to a video screen in the operation room. So this process is called laparoscopy. Laparoscope is used, and very small instrument can be inserted with the laparoscope for cutting or for removing something from inner side, etc. Now let's have the uses of keyhole surgery. Keyhole surgery is used in the process of biopsy to remove gallbladder with a stone. If we have a stone in gallbladder, then gallbladder can be removed by keyhole surgery, and to remove the stone from kidney, etc. After all this, let's have some question, brainstorming question. Now I want to check whether the subject matter is understood or not. Optical fiber is a transparent fiber in which light can travel from one end to another. Is it? Argument is added on it. Optical fiber is covered with a transparent layer called cladding. Optical fiber is made up of glass or plastic. Whether these statements and these arguments are correct or not, after the analysis, you have to select one of the options. Yeah, first option only statement is true. Optical fiber is a transparent fiber in which light can travel from one end to another. Yes, this statement is correct, but only statement is told. That's why we cannot say that this is the correct option. We have to check the argument 1 and 2 also. So it is suspended. Statement and argument 1 are correct. Optical fiber is covered with transparent layer called cladding. Yes, this is also correct. That's why we have to drop this option number 1. Now option number 2 is correct than option number 1. But till now we haven't checked second argument. So let's see this also. Statement and argument 2 are correct. No, this is not correct because argument 1 is also correct. That's why we can ignore this option number 3. Now number 4, statement and both the arguments are correct. Now let's check it. Optical fiber is made up of glass or plastic. Yes, this is also correct. All are correct. It means statement is also correct, arguments are also correct. That's why the fourth option is statement and both the arguments are correct. We have to tick it. Now, let's have some other arguments also. Whether these arguments are correct or not, we have to check all these arguments. Yes? Number 1. Endoscope is a device, but endoscopy is a procedure. Is it? Yes. This is correct. Esophagus and stomach are examined by colonoscopy. Is this correct? No. Colonoscopy is not related to esophagus and stomach. It is related to what? Large intestine and rectum. That's why this argument is incorrect. At night, sound can be heard from long distance due to refraction of sound waves. Is it correct? No, not only refraction, total internal reflection also. That's why this argument is wrong. Laparoscope is used in keyhole surgery. Yes, this argument is correct. Okay, I think I told you a lot of matter related to consequences of total internal reflection, and in two different sectors where this total internal reflection is used, that is communication and medical sector. Okay, now I want to stop this class. We'll meet in another class with some another matter. Thank you.